Hi everyone, I'm Youfang Chen. Today I'm talking about acoustic index using in a frost plot of southern China. Habitat loss, overexploitations, and other factors or the combinations can cause biodiversity loss. Several papers showing that species range get different level shrinkage, so large-scale and long-term monitoring is needed. Emerging technology and non-invasive methods are useful for monitoring on animal or plant species. Remote sense camera check passive acoustic monitoring is pervasive in research. Species identification in research is commonplace, but it's limited by expertise or rely on machine learning methods. But acoustic index can give us a chance to bypass these problems. The fundamental assumption is more species, more complex acoustic signals. We can do biodiversity research on this vegetation plot. The existing vegetation plot always get fully surveyed. So how can we integrate this information with that on animal sound? We use autonomous technology. It can help prevent damage from trampling of observers. Some vegetation plots are spanned across a large area. They can detect different effects on animal communities. Especially valuable information is tree species richness. So our research question is which variables are affecting acoustic index in landscape and vegetation-related environment? Elevation, vegetation structure, or tree species diversity? According to previous literature, we hypothesize that elevation is the strong variable affecting biodiversity, followed by vegetation structure and tree species diversity. This is our study site. We study in 7 natural reserves in Guangxi. We use canopy height, tree density, vertical heterogeneity, and tree species diversity as vegetation data. We record sound 3 times per day, but we only use morning and evening data. And we manually identified some recordings, and we found that morning is dominated by birds, and evening is dominated by insects. This is 7 acoustic index we use in our studies. We use generalized linear mixed model. Here we show full model. Acoustic index as responsible variables. And then we use Moroni test to check the spatial autocorrelation. After that, we use model averaging. This is our main result. The left table is a little bit complicated, so we can see the right table. So we found that 3 significant negative relationship with elevation, 1 negative relationship with vertical heterogeneity, and 1 positive relationship with tree species diversity. I have to mention that AEI is always opposite direction with ADI, so he showed positive here, but it's negative. Evening is similar to the morning result. We can see that 3 significant negative relationship with elevation, 1 positive relationship with vertical heterogeneity. In our result, both true taxa decrease with elevation increase. The same result as Peter's showing here. Based on MacArthur's theory, greater heterogeneity in vertical structure leads to higher animal diversity. We found 2 significant relationships between acoustic index and vertical heterogeneity. NDSI positive, ADI negative. For tree species diversity, we got interesting finding, but in surprising taxa. We hypothesized that insect sound would be affected by tree species diversity because insects tend to be more host-specific. We also found that age had the strongest relationship. ADI, AEI, and NDSI together had the next strongest relationship. ACI, AR, and BIO was not significantly related to any of the predictor variables we tested. Finally, I want to thank my supervisor, give me a lot of help in my limits. And also thank 3 fundings. Thank you.